Yeah, good afternoon to one and all. Yeah, today we are going to discuss about the volcanoes in the fourth black. So these are the natural hazards. In these natural hazards, there are several natural hazards which are comes under. There are volcanoes, earthquakes, tsunamis, landslides, so etc. All these are comes under natural hazards. So among these, today let us discuss about the volcanoes. So a volcano is a vent or fissure in the Earth's crust through which a hot lava and volcanic gases are thrown out. So generally, a volcano is a vent or a fissure in the Earth crust. As we know, in the interior of the Earth, we have three layers: crust, mantle, and core. Yes. So in which a volcano is a vent or a fissure in the Earth crust through which a hot lava and volcanic gases are thrown out. Volcanic eruptions may be either explosive or quiet. So these volcanic eruptions may be either explosive or quiet. Means there are a different type of volcanoes are there. So that the volcanic explosions, the volcanic eruptions may be either explosives or quiet. So generally, the Earth's upper mantle, the Earth's upper mantle, it is asthenosphere, you can call it as upper mantle. The Earth's upper mantle under the crust nearly molten. So it is below the crust we have mantle. So in the mantle, outer mantle and lower mantle. So our upper mantle or lower mantle. So in the upper mantle, generally, it has nearly molten. So liquid state. So magmas originate at this depth. Generally, the magmas are originate at this depth. So they migrate towards often a long faults. Generally, whatever the molten rock materials, which is called as lava below the earth surface, so this lava is always trying to comes to the earth surface. Yes. So here generally the magmas originate. The magma originate at this depth. So they migrate towards upwards of and along a faults in a volcano. So the magma rises through a chimney-like openings called vents. So in a volcano, the magma rises through a chimney-like opening which is called vent and reaches the surface as lava. So at the surface, pressure in the rising magma falls as a result dissolved gases are separated out. Such a magma is called lava. So here, below the earth surface, below the crust, in the upper mantle, so it is in molten state or liquid state. So this magma, molten rock material, you can call it as magma. This magma is always try to comes to the earth surface through the weaker zones. So it is rises through a chimney like fissure, we can call it as a vent. So through which all the gases are separated out. As a result, the dissolved gases are separated out. As a resulted dissolved gases are separated out from the magma. Such magma is called as lava. So here generally the temperature is suddenly fall down. The temperature is suddenly fall down. Why? Because at the great temperature of magma below the earth surface, it is going to be towards upward direction to the earth surface. So when you compare to the temperature below the Earth's surface and the above the Earth's surface, it's very quite common. As we know, when we are going to deeper conditions, every 31 meters, 1 degree centigrade will be rises. So in the upper mountains, a great temperature, great height, great depth from the Earth's surface. So here there is a huge temperature. It's a huge temperature. So that hundreds of temperature. So that much of huge temperature of magma, when it's rises to the Earth's surface. So as we know, the temperature of the Earth surface, it is about nearly 30 to 40 degrees centigrade. So that the temperature compared to the surrounding temperature, it is very lower than the magma. Yes, so that it is suddenly falls the temperature, and this rock material or this molten rock material above the Earth's surface, we can call it as lava. So this is the difference between the magma and lava. So there are major differences are magma is below the Earth's surface and lava is above the Earth's surface. Magma has high temperature and pressure, and lava has low temperature and pressure. Magma has gases and lava doesn't have any gases. So these are the major three differences which we distinguish between the magma and lava. Okay. So generally these are the things. Then coming to, in addition to the emission of gases and molten lavas, in the molten lavas, mostly the vast quantities of fragmental materials. In addition to the emissions of gases, not only gases, emissions of the gas, in addition to the emission of gases, a molten lavas, a vast quantities of fragmented material, fragmented materials, pyroclasts are also produced during the volcanic eruptions. So this material accumulates around the vent. These fragmented materials or pyroclasts, so they are accumulated during the volcanic eruptions. These material accumulates around the vent. A conical hill-like mass is formed in this way. So due to the accumulation of these fragmental material, a conical hill-like masses are going to form in this way, which are called volcanic cones. So the smaller cones formed around these side vents, and which are called parasitic cones. A smaller cone-like shapes, smaller cones which are formed around these side vents, which are called parasitic cones. So here I'm going to show a picture of a structure of volcano. I'm going to share now the structure of volcano so that you can able to understand. Yeah. So are you able to view this picture, structure of volcano? Is it viewable to all of you? My screen share. Yes, is it viewable to all of you? Are you able to view this?
Yes, sir.
Yeah, this is a structure of volcano. Have you see this? This is a dark black in color structure. So this is a volcanic pipe or volcanic vent. Okay, this is a volcanic pipe or volcanic vent. It means this is this spot, which is the arrow mark part, which is showing the black volcanic pipe. It is below the Earth's surface. So below the Earth's surface at mantle. So as we know, the interior of the Earth, we have three layers. Yes, first crust, then after mantle, then after core. Okay. So crust, it's about up to 2,900 kilometers. From there 2,900 to 4,200 up to mantle. Then from there to up to 6,200, 6,300, up to 6,300 around kilometers. It is core, depth of core. So this is a black colored starting point from the below. So that is the mantle area. So from which these dark color places the magma arises. The magma rises to the earth's surface from the upper mantle. So from the upper mantle, so these black colored channels or black colored fissures, which are called volcanic vent or volcanic pipes. So from which, and these are the weaker zones. So these black colored ones are the weaker zones or fissures or veins. So from which the material or molten rock material or magma, which is going to rises to the earth's surface. So this is, I will see the middle one, crater. So crater is a part where the volcanic material where the volcanic eruptions takes place. Where the volcanic eruptions takes place on the earth's surface, you can call it as that is crater. So this is a part or this is a place where the volcanic eruptions takes place on the earth's surface. So from which the volcanic material pouring on the earth's surface. From this place, the crater, the volcanic material, nothing but molten rock material. దీన్ని మనం శిలాద్రవం అంటాం తెలుగులో, molten rock material. So this molten rock material is pouring from the crater. So this not only gases, in addition to the pyroclastic materials are fragmental materials. Fragmental materials are surrounded or accumulates surround these vent or surround these crater, which are going to form a cone-like shapes or cone or hill-like masses. So which are called mostly volcanic cones. Which are called a volcanic cones. So from which crater nunchi towards left and right side there is a hill-like masses unnai kada. So huge hill-like masses. This is called a volcanic cones. Then if you see this, there is a beside the crater there is a two channels are there, towards left side and towards right side. There is another small channels are there or small volcanic pipes are there. Yes. So from which also, so where it is a chances to escape the material. Is there any chances to escape the material or chances to pour the material to the earth's surface? From those places the volcanic material is rushed to move to the earth's surface. So from these small vents, some of the small vents are also there around the crater, from which also the volcanic material is pouring. And here also there is small pores are forming, small hill-like masses are formed, which are called parasitic cones. చూడండి ఇక్కడ parasitic cones ఉన్న towards right side of the crater. Parasitic cone కనిపిస్తుందా? So this is called a parasitic cone, isn't it? So from there, from the parasitic cone somewhat distance, there is a huge ashes and fragmental cones which are formed. And this is lava flow. I will see this towards left side of the crater, lava flow. So this is lava flow on the earth's surface, so that there is a huge mass, hill-like masses are forming. So mountains are formed. So volcanic mountains, generally you can call it as volcanic mountains, isn't it? So this is due to the lava flow on the earth's surface, the mountains are going to form, mountains are takes place. So this is also again ash. So this is a structure how the volcanoes takes place on the earth's surface. So this is structure of volcano. Okay, here I will see this. So these are the different variations where we can see the fragmental ratios and the different parts. And also we can say a circular depression. Mostly we can see a circular depression found at the top of the volcanic cones, which is called crater. A circular depression. I will see this. It's a middle crater part. So this is a circular depression. Circular depression, low-lying area, depression laga ఉంటుంది. So from which the volcanic material is erupted. So a circular depression found at the top of volcanic cone is called crater. A greatly enlarged crater is called caldera. A greatly enlarged crater, if it is more than that size, A greatly enlarged crater is called caldera. A caldera is a gigantic depression. Caldera means a huge size. Same sense of meaning, but if it is the crater is the enlarged in size, enlarged a great depression, gigantic depression, the diameter of which may be 16 kilometers or more. Just you can imagine this crater depression. Crater is a circular depression found at the top of the volcanoes, which are called crater. But if the crater is a huge size depression, a even gigantic depression, so which may be up to 16 kilometers or more depression, then it is called as caldera. So most of the calderas may have resulted either due to blowing of the summit of the volcanic cone by explosive action. So this type of calderas, most short questions are asking. So the huge gigantic depression of the volcanic vent is called as caldera. So this type of calderas may have resulted either due to blowing of the summit of the volcanic cone by explosive action, or it may be due to a subsidence. So a huge depression, a huge gigantic depression, how it is takes place, how it is formed, because of due to blowing up the summit of the volcanic cone, blowing up the summit of the volcanic cone by explosive action, ద్వారా a huge material summit blow up కావడం వల్ల this type of what you can call it as a gigantic depression is formed, or in other way due to subsidence. What does it mean by subsidence? A subsidence is a which the area is sink down. Subsidence means to sinking to the down, కృంగిపోవడం అంటుంటాం కదా. So just like that, it is subsidence, so which has takes place. So in these two reasons or causes which makes the a gigantic calderas. I will see this. This is a how it is happens a calderas mostly. The subsidence is caused when the magma chamber lying below the volcano. Generally, the subsidence is caused when the magma chamber lying below the volcano is partially emptied during eruption, and the volcano then sinks into the void. Generally, how the subsidence takes place? So the subsidence takes place due to the when the magmatic chamber lying below the volcano. When the magmatic chamber, when we call it as magma, below the earth surface, the magmatic material or the molten rock material, when it lies below the earth surface, then only we can call it as magma. So when the magmatic chamber lies below the volcanic vent, magma chamber lying below the volcanoes is partially emptied during eruption. So when the magmatic chamber is below the volcanoes or volcanic vent, during the eruption, what happened? During the eruption, all the magmatic chamber or all the magmatic material is poured out, or all the magmatic material is vacated from the magmatic chamber, isn't it? So all the material from the magmatic chamber, it has been pouring away, which has explosive in the form of explosives, so that the magmatic chamber has become empty, isn't it? So below the huge magmatic chamber became empty, so that the volcanic crater is going to be depression, is going to be then sinks into the void. So that much of chamber is going to be sinking down, so that in that way the calderas are formed. So this is about the introduction of volcanoes. Let us see the types of volcanoes. So I will see the types of volcanoes. So here generally we have three types of volcanoes. There are three types of volcanoes. So generally the volcanoes are commonly do not erupt continuously, isn't it? The volcanoes commonly do not erupt continuously for long periods. So mostly they show intermittent activity. Generally the volcanoes are generally the eruptions continuously not takes place. Commonly do not erupt continuously. They are do not explosives continuously do not takes the continuous explosions. So do not take the continuous explosions. So it may take a long periods of intervals. Mostly they show intermittent activity. Intermittent activity means sometimes one again it is going to be explosive. Sometimes after some years, after some millions of years, after some few years later, then again the activity is going on. Means volcanoes are the material is poured away. So depending on the variation in the frequency, understand, depending on the variation in the frequency of their activity, volcanoes are divided into three groups. Volcanoes are divided into three groups. So they are active volcanoes, dormant volcanoes, and extinct volcanoes. Okay, active volcanoes, dormant volcanoes, and extinct volcanoes. So here, active volcanoes, dormant volcanoes, and extinct volcanoes. Three types of depends upon the frequency of their activity. Depending on the volcanic activity frequency, we are classified into three types. What are they? They are active volcanoes, dormant volcanoes, and extinct volcanoes. Okay. So active volcanoes, the name itself indicates active. They are very active. So an active volcano is one which erupts very often. Active volcanoes is one which erupts very often. Very oftenly the volcanoes are takes place or volcanic activities takes place. Such one is known as active volcanoes. They mostly occur at crustal plate boundaries. They mostly occur at crustal plate boundaries. Crustal plate boundaries, this type of active volcanoes takes place. The volcanoes that occur along a great arc around the Pacific Ocean from Chile to the East Indies are examples of the active volcanoes. So the active volcanoes that occur mostly in the crustal plate boundaries. So along a great arc around the Pacific Ocean. In the Pacific Ocean from Chile to the East Indies. In the Pacific Ocean from Chile to the East Indies are the examples of active volcanoes. Then coming to the dormant volcanoes. So the dormant volcanoes are the volcanoes which show eruptions after long intervals. I will see this, the frequency of the volcano. So the volcanoes which show eruptions means the metal comes out from the volcanic vent, which show eruptions after long intervals. After a long intervals of time is called a dormant volcanoes. During dormant period, they appear quite inactive. During dormant period, they appear quite inactive. So dormant means without anything, without no action. So during the dormant period, they appear quite inactive. So eruptions takes place after long intervals. After long intervals, we can call it as the dormant volcanoes. Then last one, extinct volcanoes. As we know, an ancient volcano which has not shown any volcanic activity. Extinct means it is over. Extinct means there is no any activities. Extinct and it means which are died. Generally in the sense of meaning, which are died. So here the extinct volcanoes, a volcano which has not shown any volcanic activity since a very long time in the geological history. The volcano which has not shown any volcanic activity since a very long time in the geological past is called extinct volcano. So these are the three types of volcanoes depending upon the frequency of the volcanic activity. Frequency of the volcanic activity, or the activity depends upon the volcanoes or volcanic eruptions. So based on that, how many types of volcanoes are there? There are 3 types of volcanoes are there. So active volcanoes, dormant volcanoes, and extinct volcanoes. Yes. So active volcanoes are the volcanic activities which are showing eruptions after, which are this volcanic active volcanoes are the which shows eruptions very often. This type of volcanoes are shows activities are showing very often. Very oftenly volcanic eruptions are takes place. Dormant volcanoes are after long intervals. This shows activity, volcanic activity after long intervals, isn't it? Which are called dormant volcanoes. Okay. Extinct volcanoes are which are not show any type of volcanic activity since a very long time in the geological past. So which are called extinct volcanoes. Okay. Let's see the volcanic products. So what are the products which are going to be released or which are going to produce from the volcanoes? The products. So generally there are 3 types of materials which are thrown out from a volcano, which are gases, molten lava, and solid rock fragments. So what products which are going to be produced during a volcanic eruption? So what type of materials which are going to be produced or released from the volcanic eruptions? So here there are 3 type of materials which are going to be produced during the volcanic eruptions. They are number 1 gases, number 2 molten lava, number 3 is solid rock fragments. Solid rock fragments. Let us see what are the gases products. So here the most important constraint of volcanic gases is steam. The most important constraint of volcanic gases is the steam. It forms nearly 90% of the total gas content. So the other chief gases in the order of abundance are carbon dioxide, nitrogen, and sulfur dioxide, and smaller amounts of hydrogen, carbon monoxide, sulfur, and chlorine. So these are the major gases. Mostly the abundance are the total gas content. So chief gases are mostly carbon dioxide, CO2, nitrogen, and sulfur dioxide. Carbon dioxide, nitrogen, sulfur dioxide, and smaller amounts of even hydrogen, carbon monoxide, sulfur, and chlorine. So these are the major constraints in gases. The constraint in gases. Okay. The density of magma and molten lava. The density of magma and molten lava is reduced by the presence of dissolved gases. Okay. Then liquid products. Liquid products. So generally the liquid emissions from volcano are known as lavas. So molten lava. Second one is molten lava. So in which mostly we can call it as a liquid emissions. The liquid emissions from a volcano are known as lavas. Lavas of acidic composition are more viscous and less mobile than highly fluid basic lavas. So generally in the volcanic eruptions, what are the a liquidous form material or liquid emission which is called as lava? In the volcanic eruption, the liquidous form or liquid emission form is known as lava. This lava is acidic composition. Acidic composition means up to 6. Okay. Acids are having pH scale up to pH 6 is acidic. Okay. So lavas of acidic composition are more viscous. So more viscous and less mobile. If the viscosity is more, and very less mobility. The viscosity బాగా ఉందనుకోండి, mobilization తక్కువగా ఉండదు. Mobility అంటే movement. The less mobile or mobility, mobilization is less mobility. Viscosity బాగుందంటే చిక్కగా ఉందని అర్థం. Viscosity అంటే స్నిగ్ధత. If the viscosity is very high, it becomes thick. బాగా మందంగా ఉంటుంది, thick గా ఉంటుంది. So that it cannot move freely. So కాబట్టి less mobilization ఉంటుంది, isn't it? Than highly fluid basic lavas. So basic lavas తీసుకుంటే, if you take the basic lavas, it is having very less viscosity. So less viscosity ఉందనుకోండి, less viscosity ఉంటే mobilization, high mobilization ఉంటుంది. Less viscosity ఉంటుంది, చాలా what you can call it as చాలా ఫ్రీగా ఉంటుంది, so that it can move, it can spread or it can move very longer distances. Okay, so the basic lavas are generally less viscosity and acidic lavas are having high viscosity. So high viscosity అంటే ఎక్కువ flowing ఎక్కువ ఉండకుండా ఏమవుతుంది, they are accumulated just around the volcanic vent, so that the steep mountains are formed. Yes, like this. Okay, next, the fluid lava results in a calm eruptions as they allow to dissolved gases to escape freely. In viscous lavas, the gases do not escape freely, so that they frequently build up an internal pressure to produce a violent eruptions. In coming to last one, solid products or solid rock fragments. So majorly we have three types of fragments in the volcanic eruption. They are gases, molten lava, and solid rock fragments. Okay. So solid fragments, besides gases and liquids, lavas, the volcanoes eject a solid rock fragments. The volcanoes eject a solid rock fragments of various size. So these rock fragments are known out by the escaping gases during the violent eruptions. When fragments of very viscous lava are blown off into the air, they solidify quickly and fall to the ground as pyroclasts. So the solid rock fragments produced during the volcanic eruptions. So generally, so the solid fragments, so besides the lava and the gases, the volcanoes are eject a solid rock fragments of various sizes. These rock fragments are thrown out by the escaping gases during a violent eruptions. So when fragments of very viscous lava are blown off into the air, they solidify quickly and fall to the ground as pyroclasts. Means pyroclast nothing but fragmented materials, pieces. So the solid rock fragments produced during volcanic eruptions, which are called pyroclasts. So depending upon the size, the pyroclast means pieces. The pyroclasts are divided into the following groups. They are mostly the volcanic blacks, volcanic bombs, lapilli or cinders, ash and dust. Depending upon the pyroclastic size, we have classified, there are several types. Volcanic bombs, very huge in size. Volcanic bombs, medium, bigger and somewhat rounded shapes. Lapillis, also which are having a gravel or piece size. And ash particles ranges between 0.25 to 4 millimeters in size. And dust less than 0.25 millimeter size. So these are the various sizes of materials or pyroclasts which are produced during the volcanic eruptions. So generally in lavas, where the gases are released during consolidation, a small bubbles may be entrapped into the rock. So these gas cavities are called vesicles. So in viscous acidic lavas, the vesicles may be so abundant. The viscous acidic lavas, the vesicles are maybe mostly in the gases in the form of they are making the bubbles. So these bubbles after consolidation which are going to be blasting, so that the vesicles which are formed on the surface of the rocks, so that these gases cavities are called vesicles in viscous acidic lava. The vesicles may be so abundant that the rock takes the form of a light spongy mass, which is called pumice, which are called a pumice. So the pumice is so light that it floats on even on water. The pumice rock is very, so that it's due to there are so much of cavities on the rock, so that it is very light, so that it can even floats on water. So the term scoria is applied to those bombs and lapillis which are spongy-like pumice, but they are more rugged and have a knife-sharp edges. So they are the volcanic blacks. Then in coming to volcanic eruptions, the central eruptions and fissure eruptions. So generally we can call it as the based on the eruptions. Volcanic eruptions of two types: central eruptions and fissure eruptions. So central eruptions means the eruptions emissions of lava takes place through a vent. Such a volcanic usually exhibits cone and crater forms. Fissure eruptions means the fissure eruptions basic lavas mostly issue a relatively quiet form inner fissures which are takes place in the fissure eruptions. So mostly we can call it as Havavian type, Strombolian type, Volcanian type, Vesuvian type, Plinian type, and Pelian type. So these are the different type of materials which are going to take place. Okay. So what are the hazards? So as we know, the volcanic activity and plate tectonics and surface of lava flows, and see the distribution of volcanoes. So there are about 800 active volcanoes on the earth crust. See, yeah, see here, generally, have you seen how it has been takes place the various volcanoes and how it is going to take place in order to take place these volcanic eruptions, and what are the materials and what type of materials which are comes out during the volcanic eruptions. And if you take the distribution of volcanoes, so there are about 800 active volcanoes on the earth's surface. So as we know, how many types of volcanoes are there? There are three types. Yes, there are three types of volcanoes. There are active volcanoes, dormant volcanoes, and extinct volcanoes. So now, even till today, so there are about 800 active volcanoes on the Earth's surface. Besides this, there are many thousands of extinct volcanic cones, most of which are under the sea floor only. So most of these volcanoes which are belongs to under the sea floor only. A great majority of volcanoes are found to be concentrated along the following belts. So generally, the majority of volcanoes are found to be concentrated along the belts only. So they are the circum-Pacific belt, most of the volcanoes, the circum-Pacific belt, the alpine Indonesian belts, the mid-oceanic ridges, and African rift valleys. Most of the volcanoes are takes place along the concentrated belts only, which are concentrated along the belts. So which belts? Mostly they are circum-Pacific belt, alpine Indonesian belts, the mid-oceanic ridges, and the African Rift Valleys. African Rift Valleys. These are the places where the volcanoes are takes place or were accompanied. So the belt around the Pacific Ocean, the belt around the Pacific Ocean contains the largest number of active volcanoes. Around the Pacific belt, the belts around the Pacific Ocean contains a large number of active volcanoes are present. Therefore, it is called a ring of fire. Pacific belt now a ring of fire, because the most number of active volcanoes takes place along the Pacific belt. That is why it is also known as a ring of fire. It seems that the volcanoes are found associated with the boundaries of the crustal plates. Why? Because the volcanoes takes place at the crustal plates. Why? Because these are the zones which are belongs to very weak. These zones are very weak. So that along the weaker zones, the volcanoes are trying to eruption. The eruptions takes place where the weaker zones are there from the below the Earth's surface. So generally, it seems that the volcanoes are found mostly. So for example, the Circum-Pacific and the Alpine Indonesian belts are the regions of recent crustal deformation, which lie along the collision edges of the crustal plates. Similarly, the mid-oceanic ridges and the African Rift Valleys represent the big tensional cracks on the Earth's surface. A few volcanoes that exist on a land away from the plate boundaries, or perhaps due to a localized heating and radioactivity. Did you observe? The most of the volcanoes takes place the weaker zones. The weaker zones, crustal plates, Circum-Pacific belt, the Alpine and Indonesian belt, or mid-oceanic ridges, or African Rift Valleys. So these are the very weaker zones. Hundreds of volcanoes which are associated only these 4 zones. Understand? Hundreds. There are about 800 active volcanoes are there, but all these are which are quite belongs to these 4 belts only. The Circum-Pacific belt, Alpine Indonesian belt, mid-oceanic ridges, and African Rift Valleys. Did you observe? Why? Because why only these places or these belts or volcanoes takes place? Because of they are the very weaker zones. They are the boundary plates, they are the crustal plates. As you know, the continental crust or oceanic crust. So this is a place where it is going to be collision to each plates. The oceanic crust and the continental crust. So these are the zones which are going to form an arc by the collision of the 2 plates, crustal plate and oceanic plate. So that there is a weaker zones is formed. Along the weaker zones, from the upper mantle, the volcanic material, the liquidous material, which is going to be trying to escape, which is going to be thrown away the material, thrown out the material from which these fissures. Understand? So this is the way of the volcanoes which takes place mostly. So generally, the hot springs, the phenomena associated with the volcanism. So most of the phenomena which is going to be associated with the volcanisms, the hot springs, fumaroles, and sometimes geysers are found in volcanic regions. So these are the associated, mostly they are associated with the volcanism, hot springs, fumaroles, as well as what you can call it as geysers. So hot springs are the commonly found associated with the volcanic activity of recent date. So surface water which penetrate the ground may be heated either by contact with the hot rocks or by gaseous emanations from the heated either by contact with hot rocks by gases from the volcanic rocks, where it re-emerge on the surface, it gives rise to hot springs. So generally, these are the things which are going to be takes place associated with the volcanoes, hot springs, hot springs. So what is it meant by hot springs? Yes? Are you able to listen?
Yes, sir.
Yeah, the hot springs mostly, hot springs means the water, the hot water which comes from the below the earth surface. Hot spring, as we know the springs, and springs generally we can call it as mostly the beaches, near the beaches. Mostly we can call it as, so where the groundwater levels are very nearer to the earth surface, mostly the water itself coming to the earth surface. So such are called as springs. Utabugalu, something else in Telugu, I can't exactly. So mostly they are the zones which has groundwater is very nearer to the earth surface, very nearer to the earth surface. So in the same way, the hot springs means the hot water comes through these vents from the below the earth surface. So along these volcanic vents from the great depths, the water comes. Why? Because this is already a zone which is designed to the event or to the fissure to the earth surface. So through which, depends upon the geological conditions, the water comes out to the surface. So that water comes from the at a great depths. So that at a great depth, what happen? High temperature is there, very high temperature and very high pressure is there. As I say, a good example, when you are going into even the open well. So inside the open well, so generally when you go into deeper conditions of the inside the open well, what happen? Your body is sweating, isn't it? Open well look మనం ఎప్పుడైనా దిగుతున్నాం అనుకోండి, ఏమవుతుంది? ఆటోమేటిక్ గా somewhat depth, కొంత డెప్త్ పోగానే ఆటోమేటిక్ గా our body is sweating. Why? Because it's high temperature. లోబడి పోతున్న కొద్ది బాడీ స్వెట్టింగ్ బాగా వస్తూ ఉంటది ఓపెన్ వెల్స్ లో కానీ ఈవెన్ మైన్స్ లో కానీ, అవునా కదా? when you go into mine, deeper mines. So when you're going to deeper side from the below the earth surface, so our body is sweating because high temperature. When you are going to deep condition, every 31 meters, 1 degree centigrade will be rise. According to that, at a great depths, the water comes from, so that the water definitely becomes very hot. So that is hot springs. Then fumaroles. Fumaroles are very closely associated with the volcanoes. So even the fumaroles also. So when the jets of steam and hot gases are discharged from a volcanic vent, it is called fumaroles. When jets of steam and hot gases are discharged from a volcanic vent, it is called fumaroles. A salt waters or the fumaroles emitting mainly a sulfurous gases, so which are called fumarole. Even geysers, which are fountains of hot water, so ejected periodically, are called geysers. So it can fountain of hot water. Fountain of what? Fountain it was so rapidly, frequently, which are periodically after some time again. So the fountain water every according to time basis, every once in a period, it is again pumping, isn't it? So geysers are same like that. Fountains of hot water ejected periodically, which are called geysers. Geysers often rise to heights of 30 to 60 meters. So after the jet of water ceases. So these are the various actions which are associated with the even mud volcanoes. So in this case, the hydrocarbon gases, mud, saline water, and some trace of petroleum are discharged from cones of dried mud. So mud volcanoes usually occur near oil fields, and they do not appear to show any connections with the actual volcanic activity. So these are the different type of associations along with the volcanoes. So the hazards, the effects of volcanoes. Is there any effects on human beings or environment by during the volcanoes?
Yes, sir.
Yes, definitely there is a huge effects on human beings or life, even biological life, or in even biodiversity, as well as environment. So it is a natural hazard. Why? Because the volcanoes are occurred naturally. No one neither created, no one neither stopped. We can't stop the volcanoes and we can't create the volcanoes, isn't it? So it is a natural hazard. It's a natural phenomenon. It's one of the natural phenomena. So the volcanoes can occur itself. So there are several effects on volcanoes. From the volcanoes, we have several effects. For example, due to the volcanoes, during the volcanoes takes place, what's happened? The huge area is covered by volcanoes, volcanic material. So volcanic mountains ఏర్పడతాయి. Is it surface? So the huge amount of area is going to occupy by the volcanic mountains. So that whatever the pre-area before takes place of volcanoes, that area is completely collapsed by the vegetation, even forestry, or even any construction places, whatever it takes place, that area is occupied by the mountains. It's a huge area. It's a hill. It's a mountain. You can imagine how much of amount of acres of land is going to be occupied during a single volcano. So it is going to be loss of space, means land. It is also loss of vegetation. It is going to loss of forestry, means nothing but deforestation. So it is also disturb the biodiversity, isn't it? And also there are, as we know, during the volcanic eruption, there are several gases. Several gases are going to be released. Carbon dioxide, carbon monoxide, sulfur dioxide, sulfur, chlorine, isn't it? There are several gases which are going to be released from the volcanoes. So are all the gases are going to be make a pollution in the atmosphere? Yes, definitely. It takes place the environmental pollution due to addition of these gases into the environment, isn't it? And also fragments, dust, the solid fragments are ejected from the volcanoes. So these are also very dangerous to the even life, the organisms. So which all takes place in all the aspect which are going to be hazardous activities, which makes an impact on the human beings or even life, even vegetation, even any living being on the earth at the place of where the volcanoes takes place. It is a great impact on the life. So it is hazardous activity, that is why which we are volcanoes comes under natural hazards. So these volcanoes mostly which has been takes place during the or most it has takes place what you can call it as weaker zones. Mostly most of the volcanoes are takes place along the belts, crustal blades or plate boundaries, isn't it? Pacific belt, African rift valleys, isn't it? So most of these belts, Indonesian belt, Alpine Indonesian belt, Pacific belt. So these are the areas which are weaker zones. And moreover, most of the volcanoes takes place under the oceanic. Because that is a very, why these volcanoes takes place under the ocean? Why? Because at the oceans are the very depressed area, isn't it? Very depressed area. They are the very depressional zones. They are the very low-lying areas. So that there is a crust thickness or mantle is very nearer to those places. Mantle. in the oceanic areas, the mantle is very low thickness. So that is why it is very huge scope to volcanic eruptions to take place under the oceanic zones. So if you take land area, so land area it's take a huge thickness in the interior of the earth. It's a huge thickness. That is why there is a very less scope to form on the land volcanoes. So whereas the oceanic area are very depressional zones, or they are the basins, they are the low-lying areas, so that just below there is a mantle. Most of the crust is occupied by the oceanic zone. Then it is very nearer to the mantle, so that from the mantle these volcanoes are erupted at the place of oceanic areas. So they are very highly hazardous. Okay, this is about volcanoes. It is very, very important. Mostly, generally asking the questions in the exams. Write about the briefly explain about the volcanoes and types of volcanoes. And most of the papers are generally was seeing this question, these questions. Okay, my class is over. Any doubts?
No, sir.
Is it clear, all of you?
Yes, sir.
Sir.
Yes, sir.
Yes, sir.
Yes, sir.
Right. Thank you, all of you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.